Welcome back to the UAV Understanding Drone course. We have completed our discussion on drones, classification, configuration, and components. By now, I'm sure that you have no problem understanding the concept of drones. We have discussed how each component plays its role and performs its function in drones. Now, in this lecture, we learn about what points we should keep in mind when designing drones. We will also learn the basics of drone designing. The primary difference between unmanned airplanes from manned airplanes is the lack of need for a cockpit area and its windows. The designing process of the drones includes three processes. First one, the conceptual designing. Second one, preliminary design. And third one, computational fluid dynamic analysis. The challenge in designing the drone is to create an aerodynamic design that can increase the endurance of the UAV. The aerodynamic analysis is focused on a UAV as a gliding vehicle, with the calculations starting with the estimation of weight and aerodynamics and finishing this stage with the best glide angle. In fact, the aerodynamic analysis is obtained for a preliminary design. This step involves the wing, fuselage, and empennage of the UAV. In order to achieve the preliminary design, an estimation of aerodynamic coefficients along with the computational fluid dynamic analysis is performed. There are different design softwares such as Solid Edge and CATIA V5. I prefer using CATIA V5 because I feel that designing in CATIA is easy as compared to Solid Edge. So what is CATIA? CATIA stands for Computer Aided Three-Dimensional Interactive Application Software. It is one of the pioneers in CAD or CAM software application packages. For beginner, CATIA V5 is better to start with. In CATIA V6, the files are not stored in the personal computer. They are stored in a central server for which Innovia, that is a Dassault Systems product, is required. The very first step in designing the drone is selecting the size of the frame. Frame size can be defined by using the specified propeller dimensions. Propeller size is given by the formula n into p, where n is the diameter of the propeller in centimeter and p is the pitch of the propeller in centimeter. For example, consider the propeller size as 12 into 3.8. Here, the diameter is 12, that is radius is half of it, that is 6, and the pitch is 3.8 cm. According to the formula, which is given as x is equal to 2 into r, where x is the minimum arm length and r is the radius of the propeller. Here we get 2 into 6, that is 12 cm, which is equal to 120 mm. Therefore, total arm length of the quadcopter is equal to x plus the arm length required to bear the loads acting on the quadcopter. When designing using the CATIA software, here are the step-by-step guidelines or instructions for all the beginners to follow. Initially, draw rough sketches or drawings on a piece of paper. Then start learning CATIA software right from the fundamentals. Designing can be done according to the dimensions, that is, you can constrain your diagram to any fixed dimensions. As we all know, we need a pen and a paper to draw your drawings. Similarly, we need a sketcher and a plane so that we can sketch the desired figure on the plane. Make sure which plane to use for drawing in your sketcher section. There are wide variety of tools to draw the sketch such as line, rectangle, profile, spline, etc. There are a wide variety of operations to perform on the sketch such as pad, pocket, boolean, shaft, groove, hole, etc. to make your sketch unique. Make sure you exit the sketcher before performing such operations on the sketch. Now design each part of the drone separately, such as frame, payload, landing gear, arms, etc. Then shift from the part design to the assembly design and start assembling each components of the drone to form a final model. Now, what is fabrication? Let's have a step-by-step guidelines even for this. The very first step of fabrication is to list all the components required to build the drone. That is, having the product knowledge is very vital in fabrication. A successful drone cannot be built without knowing which components are to be used. The specifications of each component should be known. The next step would be to estimate the weight of each component used. As shown, the table lists all the masses of the components used. This step is very necessary because weight plays a major factor in designing any of the UAVs. The next step is to calculate the estimated total weight of the components. Then start assembling the components to make sure that the essential components such as ESCs, receiver and GPS are directly connected to the flight controller, because the flight controller will monitor the operations of all these components. It will control the ESCs, thus the ESCs will control the speed of the motors. All 4 motors should be connected with the respective ESCs in order to perform their motor operation. The function of the battery is to deliver power to the distribution board as well as to the flight controller board. Power distribution board, as the name itself suggests the function, it distributes power to all the motors for their efficient working. So this was it for designing drones as of now. But there is a lot more to understand, and one lecture is surely not enough. I am sharing the basic idea to get an overview of the principles. If you have any doubt regarding any of the sections, feel free to mail me. See you all in the next lecture.